Introduction. In this chapter, we will introduce some concepts of database management. We will also introduce SQL topics. SQL Database Management System. Database Design. SQL stands for Structured Query Language. Its main function is accessing and manipulating databases. The main function of SQL that we will learn about is queries. SQL can be used to make queries to the database. Queries return us a table of data that fits some condition. For example, we may make a query that returns all the employees in a certain salary range or from a certain department. These conditions are called clauses. These clauses can vary a lot, from the obvious example above to not so obvious examples like joins. SQL is used to design the backend of websites. While not its only purpose, SQL is required to store the data from a website. Data such as user info, inventory and more. The backend of a website is the part of the website that the users do not interact with. To connect SQL with a website, we need to use a scripting language like PHP or Python. We also need to use a RBDMS program. RBDMS stands for Relational Database Management System. We will look into DBMS in more detail, both in this chapter and across the course. DBMS concepts are required to use SQL above a basic level. The version of SQL we will be using is called MySQL, and we will use a program called XAMPP to provide us an environment to work with. Database Management System. A database is basically a collection of tables that have some or no relations with each other. Each table has columns and rows. The columns all have some title like name, ID, etc. The rows are called records. Each table will have a name and, as discussed before, there will be some relationship between them. This is done through the sharing of keys. Keys are columns that are used as unique identifiers. Things like employee ID numbers or social security numbers are good examples of keys. As these keys are unique, we may decide to share them between tables, establishing a relationship between them. This model is known as the relational model. We will also look at the entity relationship model later in this course, which is used for database design. We should now look at what a table looks like. In the table above, we have some employee records. We can see that the columns all have titles. The column names tell us what we are storing in that column and give us an idea of what type of values are valid. For example, you would not expect a number in the name column. Also note that fields like name and department may have the same values in different records, but ID is always unique. That means ID can be used as an unique identifier. Thus we can assign it as a key. Now we will go over some important terms instances and schemas. A schema is a representation of the structure of a database. Logical schema. The overall logical structure of the database. Physical schema. The overall physical structure of the database. Instance. The content of the database at a given point of time. Now the logical schema is basically the definition of tables and relations. When we modify the database, we are modifying the physical schema. Modifying the physical schema should not affect the logical schema. This is called physical data independence. Database design. This is the process of designing the general structure of a database. Logical design. This is the part where we design the logical schema of a database. Logical schema should not be modified, thus it is important that we find a good collection of relations. Physical design. This is where we design the physical schema of a database. Database architecture. A database architecture has a few key components: centralized databases. One to a few cores are used for processing. The centralized databases use shared memory. Client-server. One server machine executes work on behalf of multiple client machines. Parallel databases. Several cores are used for processing. They use shared memory. Shared disk. Distributed databases. Geographical distribution. Schema, data heterogeneity. Now the database architecture can be partitioned into 2 or 3 parts. Two-tier architecture. The application resides at the client machine, where it invokes calls to the database at the server machine. Three-tier architecture. The client machine acts as the frontend only and does not contain any direct database calls. The client end communicates with an application server, usually through a forms interface. The application server in turn communicates with a database system to access data. From the above picture we can see a diagram of 2- and 3-tier architecture respectively. We can see in the 2-tier architecture, that the client side hosts the user and the application. Think of this as a video game that you have installed on your computer that may have online functionality, but can be played offline. The application is installed on your device and only when you go online does the application access the servers. It then makes calls to the database as needed. In the 3-tier architecture, the application server is on the server side, meaning that there is no direct connection to the database on the user side. An example of this would be a game that requires online functionality. Any number of battle royale type games may come to mind. While the application is installed on the client side, to actually play the game, the application servers will be separate from the client side so as to not take up too much memory. The application client then interacts with the application server on the server side. The application server will then access and make calls to the database as required. It would be remiss of us not to mention that these examples do not necessarily correlate to real-life practical examples. In fact, database systems do not work exactly in the way described when it comes to games. A practical example would be the various SQL servers that we can use. The examples above are merely to give you an understanding of the architecture. Database users. Finally, we should discuss the type of users of a database system. One may assume that there is only one type of user when it comes to database systems, which is the client that interacts with the UI. However, user in the context of database systems refers to anyone that works on or accesses the database in any capacity. The types of users are naive users, unsophisticated users who interact with the system by invoking one of the application programs previously written. You can think of this as the average user of an application. Someone using their online bank account may come to mind. This can also involve employees like bankers who only need to access parts of the database. Application programmers, computer professionals who write application programs. They have more access than naive users and sometimes even full access. These are the people that program your applications, like your banking app. They connect the application to the database but do not need to access, to say, modify the database. Sophisticated users. This is you in this course. These users directly access the database. They may use a database query language, like SQL, or use tools like data analysis softwares. These users will interact with the database without writing any programs. Specialized users. Users that write specialized database applications that do not fit the traditional data processing framework. In this chapter, we mainly discussed database system concepts. Knowledge of database system concepts is absolutely crucial when it comes to data analysis. In the next chapter, we will install an application called XAMPP and start working with MySQL.